Environmental chemistry is the scientific study of the chemical and biochemical phenomena that occur in natural places. It should not be confused with green chemistry, which seeks to reduce potential pollution at its source. It can be defined as the study of the sources, reactions, transport, effects, and fates of chemical species in the air, soil, and water environments, and the effect of human activity and biological activity on these. Environmental chemistry is an interdisciplinary science that includes atmospheric, aquatic and soil chemistry, as well as heavily relying on analytical chemistry and being related to environmental and other areas of science. Environmental chemistry is the study of chemical processes occurring in the environment which are impacted by humankind's activities. These impacts may be felt on a local scale, through the presence of urban air pollutants or toxic substances arising from a chemical waste site, or on a global scale, through depletion of stratospheric ozone or global warming. The focus in our courses and research activities is upon developing a fundamental understanding of the nature of these chemical processes, so that humankind's activities can be accurately evaluated. Environmental chemistry involves first understanding how the uncontaminated environment works, which chemicals in what concentrations are present naturally, and with what effects. Without this, it would be impossible to accurately study the effects humans have on the environment through the release of chemicals. Environmental chemists draw on a range of concepts from chemistry and various environmental sciences to assist in their study of what is happening to a chemical species in the environment. Important general concepts from chemistry include understanding chemical reactions and equations, solutions, units, sampling, and analytical techniques. Contamination. A contaminant is a substance present in nature at a level higher than typical levels or that would not otherwise be there. This may be due to human activity. Whilst a contaminant is sometimes defined as a substance present in the environment as a result of human activity, but without harmful effects, it is sometimes the case that toxic or harmful effects from contamination only become apparent at a later date. The medium, or organism affected by the pollutant or contaminant is called a receptor, whilst a sink is a chemical medium or species that retains and interacts with the pollutant. Environmental indicators. Chemical measures of water quality include dissolved oxygen, chemical oxygen demand, biochemical oxygen demand, total dissolved solids, pH, nutrients, heavy metals, and pesticides. Applications. Environmental chemistry is used by the Environment Agency, the Environmental Protection Agency, the Association of Public Analysts, and other environmental agencies and research bodies around the world to detect and identify the nature and source of pollutants. These can include heavy metal contamination of land by industry. These can then be transported into water bodies and be taken up by living organisms. Nutrients leaching from agricultural land into watercourses, which can lead to algal blooms and eutrophication. Urban runoff of pollutants washing off impervious surfaces during rainstorms. Typical pollutants include gasoline, motor oil and other hydrocarbon compounds, metals, nutrients and sediment. Organometallic compounds. Methods. Quantitative chemical analysis is a key part of environmental chemistry, since it provides the data that frame most environmental studies. Common analytical techniques used for quantitative determinations in environmental chemistry include classical wet chemistry, such as gravimetric, tetrametric and electrochemical methods. More sophisticated approaches are used in the determination of trace metals and organic compounds. Metals are commonly measured by atomic spectroscopy and mass spectrometry, atomic absorption spectrophotometry and inductively coupled plasma atomic emission or inductively coupled plasma mass spectrometric techniques. Organic compounds are commonly measured also using mass spectrometric methods, such as gas chromatography mass spectrometry and liquid chromatography mass spectrometry. Non-MS methods using GCs and LCs having universal or specific detectors are still staples in the arsenal of available analytical tools. Other parameters often measured in environmental chemistry are radiochemicals. These are pollutants which emit radioactive materials, such as alpha and beta particles, posing danger to human health and the environment. Particle counters and scintillation counters are most commonly used for these measurements. Bioassays and immunoassays are utilized for toxicity evaluations of chemical effects on various organisms. Published analytical methods. Peer-reviewed test methods have been published by government agencies and private research organizations. Approved published methods must be used when testing to demonstrate compliance with regulatory requirements.